Hello, everyone, and welcome back to another episode of, and I can't say math with Dr. War, I have to say science with Dr. War. So, my students have been pestering me all last semester to make science videos and put on my channel, and I told them I really didn't know, but I am going to test the waters to see if anyone out there is interested in the task science section of the task. And also let me know if you're interested in task social studies. I do teach math. Math is my main focus. However, at points in my career, I've been asked to teach science and I did a pretty good job of it. Many of my students passed the science. And 2 semesters ago, I was asked to teach social studies and waited to see how the students did on their social studies tests. Now, with science and social studies, that is not my content area. So when I teach it in a way that I understand, and then I can convey that knowledge to my students that they understand and interpret it and have fun with it. So hopefully, these videos are helpful to everyone. Please, in the comments, let me know if you like this series. If not, I will just dump it in the garbage. I'm going to try to make them short, not really very long, but I'm going to start with Earth's place in the universe. So I'm going to start off with Earth science, and there are three core standards that you have to know. They're medium emphasis, but they're very important. So we're going to start talking about stars. So when we talk about a star, we say in science that it's a large celestial body that is composed of gas and dust and it emits light. So we all know what a star is. You look up at night in the sky and you see stars. Way back many eons ago, travelers used to use stars to guide them. I live in New York City and I hardly ever see any stars because New York City is light polluted. So if you had to go to Times Square and look up, you would not see any stars. There's too much light. Stars are mostly visible at night when it's clear. So you have to have clear skies, not cloudy skies. And you have to be really far from the city. Again, I'm in New York City and we are light polluted. So if you go further out of the city into the suburbs or even to another country and you look up, you should be able to see stars. Now, when you look up and you see those stars, they're far, far away from us. And most of the stars are composed of hydrogen and helium. So those are the two elements that make up stars, hydrogen and helium. Now, stars are classified in groups and they're categorized according to their mass, how big they are, their luminosity, which means the energy that they output in terms of light, like how can we see them, how bright they are. And in terms of also temperature, stars are very, very hot. Their temperature is measured in Kelvin. And because they're very hot, that's why they use Kelvin. They don't use Celsius or Fahrenheit. They use Kelvin. Also, they're classified by their age and also their diameter. So if you've been watching my math videos, you know what diameter means. Now, the energy that is produced in the core of a star, so think of a star as a ball, and at its center is where its energy is being produced. And that process is called nuclear fusion. And I want you to remember that term because it's very important. So the energy that is produced in the core of the star is by the process, and this is very important, called nuclear fusion. I always want you to remember that term, nuclear fusion. It is how the energy is produced in the center of the star. Now, energy also escapes from stars in the form of light. So we see light, also in terms of radiation, heat, and also wind. Stars range in size. You have stars that are the size of Earth, and you know Earth is a pretty big planet. Well, not really that big because it's not as big as, let's say, the big giants like Jupiter, Neptune, and Uranus. So the size of Earth. and 1,000 times the size of the sun. So notice here I mentioned the word sun. Yes, the sun is a star, okay? So the sun is a star. We know that we get our energy from the sun in terms of radiation. The sun heats up our atmosphere so that it's livable. So we get enough radiation from our sun so that our water doesn't boil and we're not too cold. So it makes Earth habitable. Now, stars are like human beings. They are birthed, they live, and they die. So we're going to talk about the steps of how a star comes into adulthood and then expires at the end. So stars form in nebulas. And again, a nebula is a region which is just concentrated of dust and gas. And the gas and the dust starts to collide and contract and heat up. And all of that is due to gravity. This word is very important. All of that going on with the gas and the dust colliding and contracting and heating up, all due to gravity. Very important. Now, the second step is when the nebula then starts to contract, you get a small star being formed. And this small star we called a protostar. So you get a small star being born. You could consider this toddler star, toddler. Now, eventually, the protostar will begin nuclear fusion. Now, again, nuclear fusion is at the core of the center of the star, and that's where you have your energy. And what's happening in nuclear fusion, I'm going to explain this as simple as I can. You have the hydrogen protons being attracted to each other, okay? Then you got the strong nuclear force, fusion then starts, and that is how you get your nuclear fusion. Now, this is necessary for stars to survive. So in order for stars to survive, you have to have those hydrogen protons being attracted to each other. So basically what I'm saying is hydrogen is the fuel for stars. Like literally, it's your gasoline. It is how they survive, okay? They need hydrogen. Now, third step, okay, the star, now it's like, let's consider it like a teenager, is now going to join the main sequence. And I'm going to show you what that looks like. It's going to join the main sequence. So this is like a line where stars are located based on their temperature and their luminosity. Now, stars spend 90% of their life here. So it's like us human beings. We spend the majority of our lives working. So think about the stars have now reached adulthood and they're just working their little butts off. Okay, they spend 90% of their life here. As they're in that main sequence, you have nuclear fusion going on. Nuclear fusion is when your hydrogen starts to change into helium. So again, remember, it's like your fuel. So it's like gasoline. You need gasoline to now power your car. So the hydrogen doesn't stay as hydrogen, it changes into helium. So the hydrogen on the task test, sometimes they talk about lighter elements. Hydrogen is what we call our lighter element. And then when it changes into helium, it changes into the heavier element. Now I know helium is 2 and hydrogen is 1, so that's not really that heavy. But that's what's happening in nuclear fusion. You're changing from one element to another, and that happens throughout the life of the star. Now, where you end up in the main sequence, which is a line, it determines by your mass. So basically your size. Your size determines where you end up in the main sequence. So remember I just said the main sequence? Well, this is what it looks like. It's actually called the Hertzsprung-Russell diagram. So in class, I call it the HR diagram because I ain't have time for that tongue twister. So in class, I tell students, okay, this is your HR diagram. Now, don't get scared. On the task test, they actually give you these diagrams. They actually give you. So any question they're going to ask you about the HR diagram, they're going to provide you a picture. So breathe a sign of relief. Okay, so here is your diagram, and notice that every side of this diagram has numbers and letters. Okay, so the HR diagram is just a graph that shows your relationship among different stars. So you have different types of stars. So notice here, these ones over here are called white dwarfs. I know I'm probably saying that wrong, but my students always correct me. Here's our sun. Our sun is a star. You have a red giant, you have red supergiant, and you have blue giant. So you have different types of stars. The vertical axis here, this is your luminosity. So again, luminosity is how bright your star is. So down here, you see this has 10 to the negative 2. So down here, your stars are dull. Up here, your stars are bright, very bright. Okay, so these stars up here that are blue are very, very bright. These ones down here are very, very dull. So we probably might not see them from Earth. The horizontal is your surface temperature. So again, remember I told you that it's measured in Kelvin. So notice 40,000. These stars are hot, hot. And I don't mean like just a little bit of hot. They are hot. So here's 40,000. And again, when you are given a graph, I want you to see how the numbers are running. So this is 40,000, 20,000, 10,000. Down here at the end is 3,000. What is that telling me? That is telling me that over here, this is hot. And if I go this way, then this is cool. So these stars over here that are blue, these are your brightest stars and your hottest stars. And these ones down here that are red, these are your dullest stars, and they're really cool because they're like around 3,000 Kelvin. Now, on the task test, they really don't talk about absolute magnitude, so don't worry about this side. And they don't talk about the spectral class either, which is these that are letters O, B, A, F, G, K, M. So we're not really worried about those. What you need to know is the luminosity and the temperature. Now, the diagonal line right here, this is what we call the main sequence. So this is what I'm talking about when I talk about the main sequence. This is this diagonal line that gives you the pattern of our stars, and notice they're running from left to right. And again, the stars spend 90% of their life here in this main sequence. And as the hydrogen gets changed to helium, that is when your stars then get to change into other types of stars. So it's just like us, you know, as we go through experiences, we change as a person. You're not like how you were when you were 20, and now that you're 50 years old, you're a little bit different because you've went through some life experiences. So this is like your stars. They're going to start changing the hydrogen into helium, and then they're going to change into a different type of star. So you're not the same person as you were when you were 18, and now that you're 30, you're a totally different person. You see the world through different eyes. Now notice our sun is right here, and I know this is not the middle, but this is what the scientists say. They say that this is our sun here, and our sun is in the middle of the main sequence, and our sun is considered an average star in terms of brightness and temperature. So our sun is an average star. So we're average. At least we're not basic. We're average. Our sun is average. This is when the sun starts going to its senior citizens mode. So the beginning to the end. At some point, stars will die. At some point, our sun will die because our sun is a star and it's not going to be tomorrow. So don't get all hysterical. Not going to happen in our lifetime. Probably in our great, 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 great. I don't know how many greats you got to put on their children's lifetimes. Our star, our sun will pass away or expire. Don't say passed away, expire. So stars begin to die when they start to run out of hydrogen. And remember I told you that hydrogen is the fuel of stars. So if you start to run out of your fuel, you're going to die. It's just like a car. You run out of gas, you can't go nowhere. Okay, now gravity begins to take over when this happens. The star then begins to shrink. The outer core of the hydrogen then begins to fuse into helium. The star gets bigger, and when it gets bigger, it starts to cool down, and then it becomes a red giant. Now, eventually, some stars can then fuse helium into other elements. So remember, hydrogen gets converted to helium. Now, when the star starts to die, then some of them then start to fuse helium into other objects like carbon, oxygen, and other heavier elements like iron and so forth. Now, when your star runs out of fuel, okay, it's going to shrink under its own gravity, and then it's going to either turn into a white dwarf, a neutron star, or a black hole. And what a star turns into depends on its size. So you just don't decide like, oh, I'm dying and I want to become a black hole. It's your size that determines what you become. So if your star is a low or medium mass star, like our sun, when it leaves the main sequence, it's then going to then become a planetary nebula, and then it's going to become a white dwarf. Now, if your star is a massive star, like a high mass star, when it comes out of the main sequence, it's going to now become a supernova. And from a supernova, it's like a fork in the road. It can either become a neutron star or a black hole. So it becomes two things. Okay, either a neutron star or a black hole. So I made this little diagram of your life cycle of your stars. So again, if you are a low medium mass star like our sun, when you start to die, when you come out of the main sequence, you then become a red giant, then you become a planetary nebula, and then you become a white dwarf. Now, if you are a massive star, and I mean bigger than our sun, so you know that has to be massive because our sun is big. So a massive star, when that leaves the main sequence, you're going to become a red supergiant. So the next step is a supergiant, but a red giant, I must say. Your next step is a red giant. But when you're big and massive, you are a red supergiant, not just a red giant, a red supergiant. And then you become a supernova. And from a supernova, it depends. You become either a neutron star or a black hole. Now, you're probably like, oh my God, do I have to remember all of this? No. On the task test, they're going to provide you with a diagram. So this is the diagram that they provide you with. Sometimes it's in color, sometimes it's in black and white. And basically, you don't have to remember this. You just have to follow the arrows. So again, stars are formed in a nebula, and that's when the gas starts to contract. Now, depending on your size, you can either go left or right. Now, if you go this way, this is an average star. For us, an average star is like our sun. And then it becomes a red giant, then it becomes a planetary nebula, and then at the end of its life, it becomes a white dwarf. Now, if you're a massive star, okay, so you're born, you become a massive star. As you begin to die, you become a red supergiant, then a supernova, and then it depends. You have the fork in the road where you become a neutron star or a black hole. So on the task test, they give you this diagram. For science, they love to give you a lot of diagrams, so you're going to have to get used to reading those diagrams. And I like when you have a diagram because then you're answering the questions based off the diagram, also in your scientific knowledge. Let's try some task questions. Let's see how we do with all that information we just learned about stars. At this point, you can stop the video, read the questions yourself, and choose the answers that you think are correct. And then unpause me and then see if you got them right. So here's question 1. So it says the fuel of the star is, and notice they have these quotations like fuel. And remember, I've been using that word a lot. The fuel of the sun, like what fuels the sun? And remember, the sun is a star. Is it A, hydrogen, B, helium, C, oil and various hydrocarbons, or is it D, oxygen? I hope you chose A, hydrogen. Remember, hydrogen is the fuel of the sun. It is the fuel. Question 2. As the sun ages, it will be composed of A. More hydrogen, less helium. B. More helium and less hydrogen. C. More oxygen and less carbon. And D. Less oxygen and more carbon. So remember I talked about as the sun begins to age, it's going to then go through nuclear fusion. And nuclear fusion is when your hydrogen gets converted to helium. So the sun is aging, it's getting older. All that hydrogen is now being converted to helium. So if you're converting all that hydrogen to helium, would you have more hydrogen or would you have more helium? Well, no. You will not have more hydrogen because you're converting it. So now you're going to have less of it. So your answer would be B. As it ages, you're going to have more helium and less hydrogen. Remember, hydrogen is the fuel of the sun, and if you're using up your fuel, you're going to have less of it. Here we have question number 3. Now, this is not a multiple choice, but I thought it was a very good question, and this was recently posted on this year's Regent exam. That was in June, and I thought that, okay, I'll clip it and we'll use it. This is from June 2021. So here we have a diagram which represents the inferred sequence in which our solar system forms from a nebula of gas and dust. So they're talking about our solar system. Remember when your solar system, mostly when you hear those words, you think of the planets, you think of the sun at the center, and then other objects like comets and asteroids and so forth. Letters A through F represents different stages in its development. So now here's another graphics. You have to follow the arrows. So we're starting here at A. The nebula of gas and dust starts to collapse. Notice they have arrows going inward, so it's collapsing to the center. B. The nebula flattens and begins to rotate, and most of the matter is pulled to the center. C. The cloud becomes more dense at the center. D. Planets and other celestial objects form from gas and dust that is not pulled to the center. So being pulled to the center is what's forming our star, but there's some objects that are not being pulled to the center, and that is what formed the planets and the asteroids. E. The sun forms. So again, remember, everything is pulling to the core. That's what gives us our sun. Our sun is a star, and it gives off energy. Now the remaining dust and gas are blown away, and now you can see the planets and the other celestial objects orbiting the sun. So if you know our solar system, you know that the sun is at the center, then you have the planets revolving around the sun, and then you have asteroids, an asteroid belt that is between Mars and Jupiter, which is also revolving around the sun. And F is our current solar system, showing the planetary orbits. Yay! So here on the Regents exam, they had 3 questions. They're all worth 1 point each. And the first one, let's call this A, letter A. Letter A says, identify the force that pulled most matter to the center of the rotating disk in stage B. And remember, that force they're talking about is gravity. Gravity is what pulled everything to the center. All right, let's look at B. Identify the process that produces energy in the core. That's your keywords here. That produces energy in the core of the sun at stage E. So at stage E, we have our fully developed star, which is the sun, and it has now entered the main sequence. Like, what is producing that energy? And notice they're saying combining light elements into heavier elements. Well, process, that process they're talking about is nuclear fusion. Always remember that. That process is nuclear fusion, which is combining the lighter elements into heavier elements. That is where hydrogen is getting converted to helium. And C, most asteroids are formed in a belt between 322 million and 478.7 million kilometers from the sun. And they want you to identify two planets, only two planets located on either side of the asteroid belt. So one of the things you have to know is the order of the planets from the sun. And for my students to remember this, I give them this saying: my very excellent mother just served us noodles. This helps us remember the planets. So this M here is Mercury. Mercury is the first planet that's closest to the sun. So you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Again, M is for Mercury, V is for Venus, E is for Earth, M is for Mars, J is for Jupiter, S is for Saturn, U is for Uranus, and N is for Neptune. Now you also have to remember that the asteroid belt, okay, and I'm going to draw a belt. I can't draw, so let's just think of this as a belt. The asteroid belt lies between Mars and Jupiter. So your answer for this would be Mars and Jupiter. That's your answer. Let's look at some more multiple choice. Number 4 says most of the radiant energy released by the sun results from the process of, so they're talking about, okay, how is the energy released? You have nuclear fission, nuclear fusion, combustion, and electrical generation. One of the things I tell my students, don't choose words that you never heard in class and in the lecture. Now, students go, oh, okay, if we're talking about energy in the sun, it's nuclear. So we know it's not combustion and it's not electrical generation. Like, where did electricity come from? So you're like, is it fission or fusion? Always remember the answer is fusion, nuclear fusion. We're going to talk about fission later. Fission occurs when you're splitting molecules, and that's when you're splitting uranium, which they use for power plants, like when they get energy from a nuclear power plant. That's called nuclear fission because they're trying to split atoms. We'll talk about that later. But always remember the word is fusion. Fusion. Question 5. The most abundant element of the sun is. Like, what does the sun have a lot of? Is it hydrogen? Is it helium? Is it carbon? Is it oxygen? Well, ask yourself this. What is the fuel for the sun? Hydrogen. Hydrogen is the fuel of the sun. Here's another look. I picked this question because sometimes my students, they totally forget some of the key words and phrases we talk about. So here they give you a reaction. It says the reaction below represents an energy producing process. So notice you have hydrogen, lighter element, plus hydrogen, lighter element. And remember I told you what happens when you put the two hydrogens together, the two hydrogen protons. You're going to get helium, which is a heavier element plus energy. And there says, oh, this reaction represents how energy is produced. Now, where is this energy being produced? I tell students, once you see hydrogen and helium, stars, stars, that's the only place this is happening. It is not happening in nuclear decay. It is not the movement of crustal plates. It has nothing to do when water condenses in the Earth's atmosphere. Once you see hydrogen and helium, stars. And notice they didn't use the word stars. They don't use it. They like to use sun. But you must remember the sun is a star in the sun by fusion. And remember I told you that when it comes to the life cycles of the stars, they'll give you a picture. So again, here is a picture, okay? They give you a graphics. We've seen this before in color, but now it's in black and white. And the question they're asking is, according to the diagram, a star like Earth's sun will eventually. So even if you are on the task test and you didn't even learn anything about stars, if they give you a graphics, you should be able to follow. So the first thing I'm going to do is try to find Earth Sun. So over here, Earth Sun type star. I gave this to my class as a question in the test, and because my first graphic, I had Earth up here, everyone went up here, and I was like, no, you have to look and find. You can't assume that every picture is going to be the same. So I find Earth's Sun, which is number 2, Earth Sun type star, and notice that it becomes a red giant. Do you see the word red giant? Okay, no. Then it becomes a white dwarf, and this graphic actually had something else, black dwarf. And they were so confused. And I was like, just because I didn't say anything about this black dwarf, go with what you see here. So you see white dwarf and your answer is C. Change into a white dwarf. You're not going to change into a supernova. Supernova is if you're a massive star, which means up here, and become a black hole. This says black hole, doesn't say black dwarf, black hole. And it does not become a neutron star, okay? Does not become a neutron star, which is here. So just follow the diagram and you'll get your answer. And last but not least, I have another one. So again, here's another diagram. And this one says stars like Earth's sun most likely form directly from A. So where do stars form? You got to go from the beginning, right? So this is Earth's sun type star. So I would have to go this way. And we all know that stars form in a nebula. I hope this lesson has been helpful with talking about Earth's place in the universe. I started off with stars. I hope these types of questions help. Please let me know in the comments if you like these science topics being talked about. And I'll make more of them. But I'm just testing the waters. So I hope this has been helpful, and good luck on your science task examination.